In this lesson, what we're going to cover is actually permutation and combination. When we say combination, actually, the order is not important. Okay? Group of things where order does not matter. An example of this, of course, is a group of students. Okay? A group of students is an example of combination because it doesn't matter where the student or where a student in a class sits. Or anyway, it depends on the teacher, but usually we don't care about the arrangement of the students, right? So a group of students is an example of combination. A football team, of course, is also a combination because usually we don't arrange. Of course, in a game, we can also arrange them the way we want, but usually the moment they move and run inside the pitch, we don't care actually about the order. Fruit salad is also an example of a combination because we just mix our fruits and we don't care about the order. So that is combination. And we have two types of combination. One is combination with repetition. The other one is combination without repetition. The examples I gave here are combination without combinations because we have three without repetitions. Why? Because I have no space here. Okay, let me just rewrite it. Football team, group of students, and fruit salad. These are examples of combinations without repetition. Why? Because every student is unique. You cannot duplicate a student, of course. Same with the football team. Fruit salad, it can be a combination with repetition. It can be both. Or also, it can be a combination without repetition. Now, let me give you specific examples of combination with repetition. A very clear example of this is the coins in your wallet. The coins in your wallet is an example or are examples of combination with repetition because we don't care about the order of the coins, but the coins can be repeated. Okay, it could be 50 paisa, it could be 20 paisa. If you have 20 paisa, for example, it could be 10 paisa, it could be 50 paisa again. Okay, let's just have specific examples. It can be 25 paisa, for example. And again, 50 is repeated, 50 is repeated. So in this particular scenario, in your wallet, you have 3 coins, 50 paisa, and you have 1 coin, 25 paisa, for example. So coins or notes in your wallet, okay, it could be 50 reals, 20 reals, 5 reals, 10 reals, and 5 reals again, and 50 reals again. So the notes can be repeated, and we don't care about the order of the notes in the wallet. Okay, so these are combinations. When we say permutation, permutation is also a combination, but it is an ordered combination. It means that the order is important. Order matters actually. Example of this is your pin. Okay, your pin could be 849 026. Okay, the order is important. You cannot change the positions of 8 and 4. You cannot write 489026. It doesn't work. But we have two types of permutations. Permutation with repetition. An example of that is the one I gave, the password, because we can have 8499263 as the PIN or the password where 9 is repeated. Okay, so passwords usually are examples of permutations with repetitions. Okay, and the other one is permutation without repetition. Okay, when we arrange our students in a row, arranging students in a row, this is permutation without repetition because we are using the word arranging. That means the position is important and every student is unique, so without repetition. Okay, it could be student A, B, C, D, E. You cannot repeat E. E is unique. Okay, this usually happens when we have a ceremony, for example, where we arrange our students according to some criteria or restrictions. Okay, but in a class, we don't usually arrange our students. Another example of permutation without repetition is, of course, in a contest, the awards in a contest, first, second, third, and fourth, for example. Okay, it is in order, and you cannot give the first, for example, to two people. Okay, unless otherwise, you change the criteria and you have a tie and you give, the award to both people, for example, or both persons, awarding them like second place, depending on your decision actually. But usually awards in a contest are a permutation without repetition. Why? Because every award is given to one person only. Okay, so let's proceed to some examples on how to solve problems involving combinations and permutations. So here you're going to find the number of combinations without repetition from the first or from this set. Okay, so first is to count all the elements inside. So we have KLMN, TRSQWP. So we have 2, 4, 6, 8, 10. And every group or combination have 4 elements. An example of this is KTRS. Okay, but KTRS can be written as TRSQ. I mean K. These are equal actually because order is not important. So KTRS is equal to TRSK. So this will be counted as one only, or it can be written as RSKT. So these three actually will be counted as one only in combination. So usually the number of combinations is lesser compared to the number of permutations, because the number of counts will be reduced because we don't care about the order. So here, the first thing that we're going to consider, of course, is the number, that is our n, the total number of elements, because the formula is n factorial over r factorial times the quantity of n minus r factorial. This is the formula for combination without repetition. Okay, so you can use your calculator to get the answer. So our n is equal to 10 because the total number of elements is 10, and r is equal to 4. Okay, because we are going to have every combination having 4 elements. So using the formula, okay, we replace our n to 10 and our r, because we're going to choose 4 every time. As I said, an example of that is this: 4 elements in every group. So below is n minus r factorial, that is 10 minus 4 factorial. So the answer here is actually 210. You may check this one manually or using your calculator. Manually, of course, it is 10 times 9 until 1. Okay, 10 times 9 times 8 and 7, 6, 5, 4, 3, 2, 1. And below is 4 times 3 times 2 times 1. That is for the 4 factorial, and 6 factorial, 6 times 5 until 1. So this can be deleted. Okay, and this, of course, 10 times 9 times 8 times 7 over 4 times 3 times 2 times 1 will be 210. So please check this during your free time. Okay, so let's proceed to the next. The second one here is also combination without repetition. We have 20 workers, and we are going to group them where every group has 5 people. So our R here is equal to 5, and our N is equal to 20 people. Okay, so the answer is basically 15,504 using the formula. I want you to check this again during your free time. All right, so let's proceed to the next here. This is about permutation. Whenever you see the word PIN, lock, passwords, ID numbers, ATM PIN, bank account number, phone number, all of these are examples of permutations with repetition. Why with repetition? Because we are allowed to repeat. Like your password, it could be actually 7AB9965, where 9 is repeated. The formula for permutation with repetition is the simplest. The formula is just n raised to the power of r. So here, if a 6-digit pin is created from XYB 01498, what is the total number of pins possible? This formula is actually used by banks and most companies to generate passwords. Okay. For example, NBO in Oman uses 4-digit as the pin. Could be 5092. It could be 9963. So if we use only 4-digit and there are, of course, 10 possible. We have 10 possible digits, right? That's why we call this as decimal number system, because we have 2, 4, 6, 8, 10, base 10. So using the formula, actually, the answer here will be 10 raised to the power of 4. So there are actually 10,000 possibilities. That's why banks are very confident that the OTP is safe, because every time we generate OTP, there are actually 10,000 possible outcomes there. Okay, so here our n is equal to 8 because we have x, y, b0, 1498, and r is equal to 6 because we're going to create, like 6-digit pin. So using the formula, we have n raised to the power of r, 8 to the 6 is 262,144. Okay, so here, if a 7-digit phone number is created from 1 to 9, what is the total number of phone numbers that can be generated without the 0? So here our n actually is equal to 9, our r is equal to 7, so the answer is actually 4,782,969 possible outcomes. Okay. Okay, here you're going to find number of different words that can be formed using these letters. So these letters, LADDER, have some repeated, elements. So the repeated letter here is D actually. So we are going to form different words using the word ladder, with or without meaning. An example of that is REDDAL, Redal. Okay, or it can be DER, then D again here, then we have AL. Okay, so even if the words have no meanings, we still count it because with or without meaning. So we are just rearranging. Now, if you're going to look at DD here, you have LADDER, ladder. If you're going to change the position of these two, it doesn't matter. It will be the same ladder. So the number of counts actually reduces because some letters are repeated there. Okay, so if some letters are repeated or some elements are identical or repeated, we are going to use a different formula because, as I said, the number of counts will be reduced because when you change the positions of both of these when they are beside each other, it doesn't create any other meaning or it doesn't form another word. Unlike this one where we separated D and the second D, the first D and the second D, it created a different word. But if they are actually beside each other, it doesn't create a different word. Okay, so for that, it has a reduction in terms of the meaning. I mean, in terms of the total count. Okay, so first is to identify the frequencies. You count how many L's, how many A's, how many D's, E's, and R. So this is the first step. As you can see, D is repeated. So we will be using a different formula. The formula actually is n factorial over n1 factorial, n2 factorial, n3 factorial until nk factorial. So n is the total number, okay? Total frequency, please take note. Total frequency. So we add all of this, it's 6. That's why we have 6 factorial. And we are going to divide by the frequencies which are greater than 1. So here there is only one greater than 1, that is 2. So only one there. So that's the meaning of N1, N2, N3 until Nk here. Because in some cases, for example, if it is like this, okay, for example, success. Here C is repeated and S is repeated as well. So we have N1 and N2. It can be more like mathematics, for example. Okay, there are like at most 3 letters there repeated. M, okay, you have T, okay, and A. So 3 letters are repeated. So we have N1, N2, and N3. It depends on how many elements or letters with frequencies greater than 1. So in this case, there is only 1. So we're going to use only 2 factorial and get the answer. So the answer is actually 360. Okay. Right. So that's how to do it if some elements are repeated. Let's have another example. Here, see, this is what I'm saying. Success, for example, has 2 letters repeated more than once, like S and C. S 3 times, C 2 times. So we add all, we have 3 plus 1 plus 2 plus 1 is 7. So 7 factorial. And here we have N1 and N2 factorial because 2 letters have frequencies greater than 1. So the answer actually is 420. Okay, so let's proceed to the next. Okay, here A1, B1, C1, D1, E1, and F1 are 6 students. So these are 6 students. In how many ways can they be seated in a row if there are no restrictions in the sitting? So in the sitting, if there are no restrictions and we rearrange our students, that means when I say restrictions here, A and B, for example, they can sit beside each other, or it's fine if they don't sit beside each other. That's the meaning of the restrictions here. But here we are talking about not combination. We're talking about permutation. Anyway, it is combination, but special. It's ordered combination. This is an ordered combination because we talk about how many ways they can be seated in a row. Okay, so for the first one, there are no restrictions. That means, as I said, A or B, C, D, they can sit beside each other, or fine if they sit anywhere. Okay, so here the answer is n factorial only. So you have 6 factorial. That means 6 times 5 times 4 times 3 times 2 times 1. So 720 is the answer. Okay, we just multiply from 6 until 1 because there are 6 students. And this is permutation without repetition. Why without repetition? Because every student is unique. Of course, F1 is alone. F1 will not be duplicated. Okay. Actually, you can also use the formula for permutation without repetition. But for small numbers, actually like 6, we can just use the factorial directly, or you can use n factorial over n minus r factorial. It will be the same 720. This formula is actually the formula for permutation without repetition. So that will be 6 factorial over, you have 6 minus 6 factorial. Because our n is 6 and we're going to choose 6 every time. Yeah, we are not removing any student every time we rearrange. We are just rearranging them. Okay, but every time it is 6 students. So 6 minus 6. So 6 factorial over 0 factorial is 6 factorial over 1. Okay, because 0 factorial actually is 1, not 0. So that is why the answer is the same here. Okay, so the second one, we have restrictions. A1 and B1 should sit beside each other. Okay, so what are we going to do? We're going to put A1 and B1 together, one group. Then we have C1, D1, E1, and F1. Now, the total group will be only 5 instead of 6. So total, talking about, because we are grouping now, this is like one student, another student, another student, another student, and A1 and B1, they are combined together like one group. Okay, this is a technique to get the number of permutations when we have a restrictions where A1, B1 should sit beside each other. So this is 1, 2, 3, 4, 5 only. So the answer will be 5 factorial over, you have to count how many students in this group, 2 factorial. Okay, so that affects our answer. Basically, this is multiplication, not division. Sorry. Okay, why did we divide it? It should be multiplication. Okay, so the answer is 240. Now, for the letter C, A1 and B1 must not sit beside each other. So actually, B and C are complements, opposite. B is the complement of C, C is the complement of B. Because A1 and B1, they should sit beside each other. Here, A1 and B1 must not sit beside each other. It's complement. So it means it is the whole minus the opposite. Okay? We call this actually as complementation rule. Complementation rule, 1 minus PA. 1 is 1 whole minus the opposite. So P not A equals 1 minus P of A. So the probability of not A, getting not A, is equal to 100% the whole minus the opposite of not A. Okay, in probability. So we can apply this in counting the number of permutations. So A1 and B1 must not sit beside each other is the opposite of this. So the whole is 720. This is without restrictions, the total possibilities. Okay, involving these 6 students. That's the whole total. Total number of permutations when we don't have any restrictions. Minus 240, the opposite of must not sit beside each other, equals 480 possibilities, 480 permutations. Okay. All right, so these are the answers. Let's now proceed to the next. Find the number of combinations with repetition if 3 coins are selected. As I mentioned a while ago, when we talk about coins in your wallet or pocket, the order is not important, so it is combination. But repetition is allowed, right? Because C1, for example, coin 1 can be repeated many times. So the formula is different. The formula is the quantity or the group of R plus n minus 1 factorial over R factorial times the quantity of n minus 1 factorial. First, you count how many coins. There are 6 coins there. Okay, so let me just answer that. And our R here is 3. 3 coins are selected, so we choose 3. So N is 6, 1, 2, 3, 4, 5, 6. So using the formula, we have 3 plus 6 minus 1 factorial, then over R factorial, that's our 3, should be 3 here. So we have 3 factorial, and then we have 6 minus 1 factorial. Okay, so this will be basically 8 factorial over 3 factorial times 5 factorial, because you have 9 minus 1. This is 6 minus 1 equals 56. So I want you to check the answer of this during your free time. Factorial actually is shift x raised to the power of -1. Try to find this in the calculator. Try to search for this in the calculator. You will find it there. Okay. So next is how many part B, how many 3-digit numbers can you make using the digits 1, 2, and 3 without repetitions? So 3-digit numbers, right? So our N here is this 3, and our R is also 3, because we're going to form 3-digit numbers like 3, 2, 1, 1, 2, 3. Okay, 2, 1, 3. These are the examples. So it means we're going to use the digits every time, all the digits, because we're going to form 3-digit numbers. Okay, so basically you can immediately use this because N and R are equal. If N and R are equal, you can use N factorial only. So 3 times 2 times 1 is equal to 6. Or of course, you can use the formula. You have N minus R factorial. You're going to get the same answer. Here, how many different words you can make using the letters A, B, E, L? As you can see, there are no letters repeated, no identical letters. Every letter is unique, A, B, E, and L. So how are we going to solve this? Yeah, of course, our N is 4. Our R is also 4, because we have to use all the letters every time, like Abel, Leba, Ebal. These are the examples. We are just rearranging the letters to form different words with or without meaning. Okay, so you can use again N factorial like here. So 4 times 3 times 2 times 1 equals 24 possibilities. If you keep on going, you will end up having 24 all in all. I started with 3, still 21 more. Number 3, how many 2-letter combinations can you make using the letters X, Y, Z, M, and K without repeating the letters? So it's very clear. It's combination. So we count 1, 2, 3, 4, 5, and our R is 2. Because 2-letter combinations, it could be XY, XZ. Okay, we have MZ. These are the examples. Every group has 2 letters coming from here. Okay, so the formula is N factorial over R factorial N minus R factorial. So we have 1, 2, 3, 4, 5 over 2 factorial, 5 minus 2 factorial. So the answer there is actually 10. So please check this during your free time. Okay, so let's proceed to the next. How many 4-digit password we can create out of the following digits, assuming that repetitions are allowed? And how about if repetitions are not allowed? Okay, so if repetitions are allowed, this talks about password. So password is permutation. So in the beginning, you have to identify first whether it is a permutation or combination, unless otherwise it is mentioned like number 1, 2, and 3. Here is not mentioned, but it's very clear. Words, okay, permutation. 3-digit numbers, okay, permutation. Here is clearly mentioned. Here is not mentioned, but the word password itself or PIN tells us that it's about permutation. So permutation with repetition, the first one, the formula is n raised to the power of r. Repetitions are allowed. So there are 10 digits from 0 to 9. 10 to the 4th equals 10,000 because we are trying to create password using 4 digits. Okay. Now the other one is repetitions not allowed. So this is the answer for the first 4, 1. 4, 2. Second question is permutation without repetition. Without repetition. Okay, so you know the formula, n factorial over n minus r factorial. So we have 10 digits, 10 minus 4 factorial. So the answer is 5040. So please check this one during your free time. Our n is 10, we have 0 to 9 and 4-digit password. So 10 minus 4. Okay, so that's how to answer number 4. Let's go to number 5. How many different ways can the letters of the word mathematics be arranged? Okay, so this one, as I said, the formula is n factorial over n1 factorial n2 times n3 until the last nk. So mathematics, okay, let's try to rewrite this. Same font. Okay, mathematics. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our n is 11. And m is repeated 2 times, a 2 times, and t 2 times. The rest only 1 time. So 11 factorial over 2 factorial times 2 factorial times 2 factorial. Okay, so open and close here so you will get the correct answer. So you will have 4,989,600 permutations possible. Okay, so that's it. Actually, these are the number of permutations, different ways of rewriting the letters mathematics in the word mathematics. Okay, here, how many ways can the first and second place be awarded? I talked about this a while ago. This is permutation without repetition, because you cannot be the first and be the second also. If you are the first, you are the first. If you are the second, you are the second. You cannot say, I won the contest, I was the first, and I was as well the second. Yeah, only one award. So there are 10 people. So first and second. So our R is equal to 2. our n is equal to 10. So you can use the formula that is 10 factorial over 10 minus 2 factorial equals 90. Okay, because awarded to 10 people, so our n is 10, and our r is 2 because we have first and second. Or you can multiply directly 10 times 9 is equal to 90. Okay, this is the first. During the first peak, there are still 10 people. During the second peak, because the first can be awarded only one time, only 9 people. So it keeps on reducing. So 10 times 9 is also 90. This is the shortcut actually. So if I'm going to say how many ways can first, second, and third be awarded to 10 people? 10 times 9 times 8. Okay, the answer is 720 times or ways. Okay, so I guess that's the end of this lesson. Thank you so much for watching. Until the next time, bye-bye.